The DR self-propelled brush mower is a reliable and versatile piece of lawn equipment perfect for all your yard and field clearing needs. Its deck was recently optimized to increase mowing performance by mechanical engineers from the University of Vermont Seed Team 17. Let's look at their design process with Kevin Roback, Matt Borja, Anthony Berman, and Cam Ruffel-Degnan.
So DR's most recent brush mower, the AT4, experiences a problem where not enough grass is actually leaving the mower than is coming in, and as a result, the mower bogs down and then eventually it stalls, and that makes for unhappy customers trying to cut big fields for a long period of time. So because of this problem, not only do we have angry customers, but DR is also losing business to bigger vendors that like to carry general lawn equipment.
So our main objectives for the project were first and foremost the performance. We wanted to make a product that would be able to effectively discharge plant material and not bog down. We also wanted to make something that is marketable, so we were aiming to keep the additional costs below $100. We wanted to make it something that's easy to manufacture. What this meant for us was building it out of 12-gauge steel to match the construction of the current deck. And we wanted to make it easy to adjust. So we wanted to have something that could easily be interchanged. So if we add a discharge, we want it to be able to have a mulching attachment for that as well.
So in selecting our design, there are a few modifications we considered making to the AT4 deck that DR currently has in production. These included reducing the amount of sharp corners in the deck geometry to create a smoother path for vegetation to flow through the deck. We also thought about adding turning vanes for the same effect. And then we considered different types of blade geometry to add different amounts of throw to the vegetation to increase lift. But ultimately, what we ended up doing was creating this discharge in order to allow a very unrestricted exit path for vegetation as it flows out of the deck.
So for those who are not too familiar with lawn equipment, there are basically two main designs for lawn mowers: mulching decks and decks with discharges. With a mulching deck, you get much finer cut quality. However, you have to mow the lawn a lot slower. And with a discharge deck, you have the advantage of speed, but the cut quality isn't so good. So what we have done for our design is make it interchangeable between a mulching deck and a discharge deck. So here we have a detachable discharge, which will shoot the grass out. However, it won't give you as good cut quality. And with a mulching attachment, it basically blocks off the whole side here, so you can get much finer cut quality. However, you have to go a lot slower.
With our design selected, we then use SolidWorks to model our deck and discharge. Next, we use the CFD program to analyze the flow through the deck and discharge to ensure that they would achieve our objectives and requirements.
So after creating our discharge prototype, we wanted a way of validating the performance of the prototype. And to do this, we used a sensor that detected the actual rotation of the blade going on underneath the deck. Right here we have a protective cover to ensure safety of operators. So the way that it works is that it uses this sensor here and it relays data to an Arduino microcontroller. And from there we can actually read the rotation of this pulley, which is attached directly to the blade underneath the deck.
The next segment of video you're about to see is the testing of our deck's performance versus the old one using the sensor mentioned previously. Lines of pre-measured hay were used to simulate some of the most extreme conditions the mower may encounter. In this trial, the mower outfitted with the old deck stalled in the first gear. With our new deck, the mower was able to make it through in first gear without any significant reductions in RPM or stall. Throughout this project, our team applied the engineering design process to come up with the most optimal solution for our discharge problem to satisfy our client and their customers.